Hi, mystery investigator. Before we dive into today's mind-bending topic, don't forget to hit that subscribe button for more intriguing explorations into the unknown. Imagine a world where your thoughts can be heard, not just by you, but by others as well. What if I told you that scientists are inching closer to making this a reality? Researchers have been decoding brainwaves, capturing phrases that match later brain activity, revealing a profound connection between our inner voice and external speech. This fascinating journey into the realm of neuroscience is not just about understanding how we think. It's about bridging the gap between thought and communication, a leap that could redefine human interaction. In a groundbreaking study by UC Berkeley neuroscientists Brian Paisley and Robert Knight, they successfully decoded brainwaves to predict what a person has heard. Their research, published in January 2012, demonstrated that the electrical activity in the brain could be interpreted to reveal the auditory experiences of individuals. This research not only provides insights into how we process sound, but also raises questions about the nature of our inner voice, the thoughts we silently narrate to ourselves. The implications of their findings have sparked a wave of interest across the scientific community, paving the way for further exploration into the intricacies of human cognition. What's particularly intriguing is the technology used in these studies. Researchers employed advanced techniques to analyze brain activity, focusing on the auditory cortex, the area responsible for processing sounds. By using sophisticated algorithms, they could identify patterns in brain activity that corresponded to specific sounds or phrases that participants had heard. This level of precision opens doors to understanding how our minds work, especially when it comes to inner speech. The potential applications of this technology could extend beyond mere curiosity, possibly aiding in the development of devices that help those with communication disorders express their thoughts more effectively. At Stanford University, another team has taken this research further, successfully decoding the brain signals behind our inner voice with an impressive accuracy of around 74%. Aaron Kunz, the lead researcher, explained that they worked with participants who had limited ability to speak due to conditions like ALS or stroke. The goal was to explore whether these individuals could communicate by simply imagining words. By focusing on the speech-motor cortex and using microelectrode arrays, they recorded the electrical signals of neurons firing in real time. This innovative approach not only demonstrates the potential for bridging the gap between thought and speech, but also highlights the remarkable adaptability of the human brain in the face of adversity. During their studies, participants were instructed to imagine saying specific sentences while their brain activity was monitored. The researchers created a database of patterns associated with different phonemes, the building blocks of speech. By training their models on this data, they could later decode what thoughts the participants were attempting to express. This technology represents a monumental leap in understanding how thoughts can translate into audible speech, even without vocalization. The implications for individuals with speech impairments are profound, as this could lead to new methods of communication that bypass traditional barriers. Yet, the implications of this research extend beyond communication. A 2025 study led by psychologists at UNSW Sydney revealed that auditory hallucinations in individuals with schizophrenia may arise from a failure of the brain to recognize its own inner voice. In healthy individuals, when we think about speaking, our brain dampens auditory responses, effectively filtering out self-generated sounds. However, for those experiencing auditory verbal hallucinations, this prediction mechanism breaks down. Instead of suppressing the auditory activity, their brains react more vigorously to imagined speech, mistaking it for external sounds. This groundbreaking discovery has significant ramifications for our understanding of mental health and the mechanisms underlying psychotic disorders. This misattribution of inner speech as external auditory input provides the strongest evidence yet for the theory of misattributed inner speech. Interestingly, the findings suggest that there may be biological markers that could help identify or predict psychosis before its onset. This could revolutionize how we approach mental health conditions, offering new avenues for early intervention and treatment. Furthermore, as researchers continue to explore the neural pathways involved, they may uncover additional insights into the complexities of human thought and perception. The brain's ability to distinguish between internal and external speech is a fascinating aspect of our cognition. When we engage in inner dialogue, the brain creates an efference copy, a neural signal that predicts the sounds we are about to produce. This mechanism helps us differentiate our voice from external noise, ensuring that our inner thoughts don't overwhelm us. However, as the research indicates, when this system fails, it can lead to profound consequences, such as auditory hallucinations. Understanding this process could lead to targeted therapies that help restore the brain's ability to accurately interpret its own signals. In a practical demonstration of this concept, researchers conducted experiments where participants listened to specific sounds while imagining saying those sounds. The results were striking. In healthy individuals, brain activity decreased when the imagined sound matched the external stimulus, reinforcing the idea that our brains are adept at filtering our internal monologues. Conversely, individuals with auditory hallucinations exhibited heightened brain activity in response to inner speech, revealing the disruption in their predictive mechanisms. This contrast not only highlights the importance of the efference copy in healthy cognition, but also underscores the potential for developing interventions that target these neural pathways. Understanding how our brains interpret inner speech not only sheds light on conditions like schizophrenia, but also enhances our grasp of human cognition. It suggests that our thoughts are not merely private experiences, but can be decoded and understood in ways we never thought possible. This revelation raises profound questions about the nature of consciousness and the boundaries of human communication. As we delve deeper into the workings of the mind, we may discover that the line between thought and expression is far more permeable than we previously imagined. As we continue to explore the intricacies of the brain, the potential applications of this research are limitless. Imagine a future where those unable to speak can communicate their thoughts seamlessly through brain-computer interfaces, or where mental health professionals can identify the early signs of psychosis through brain activity patterns. The implications for both neuroscience and mental health are staggering, offering hope for innovative treatments and a deeper understanding of the human experience. So, what does the future hold? As scientists refine their techniques and deepen their understanding of the brain's inner workings, we may be on the verge of unprecedented breakthroughs in how we comprehend and interact with the world around us. The voice that repeats our thoughts seconds before we consciously think them may soon not just be a whisper in our minds, but a bridge to a new era of communication. If you found this exploration intriguing, make sure to like and comment below. Don't forget to subscribe to stay updated on our next adventure into the mysteries of the mind. What will we uncover next? Tune in to find out.